Well, welcome everybody to the August 2017 Mississippi PowerShell User Group virtual meeting. Tonight we have David Lamb presenting an introduction to managing Windows DNS servers with PowerShell. So take it away, David.
All right. Well, thanks, Mike and Ron, for having me present tonight. I've been looking forward to doing this for a little while here, showing everybody a little bit about managing Windows DNS servers with PowerShell. Up front, full disclosure, this is a brand new presentation, so it may or may not still be a little rough around the edges. So if you have any questions or something seems unclear or you have any other comments, feel free to speak up and let me know at any time. So with that, introducing myself. Now I've been working in IT since 1995 and working with Windows Server since version NT4 came out. Probably about 15 plus years of that has actually been specifically with Windows Server. Like I said, I've earned my first MCSE in 2001 on NT4, and I'm currently working on my MCSE for Server 2012. Now, the question of who needs PowerShell is kind of my brief story of shame. That in 2006, when PowerShell first showed up on the scene, I was building a presentation, building an image for the company I was working for at the time, and went through the updates. And there's this one came up, and I thought, PowerShell, what's this PowerShell thing? So, more powerful command prompt scripting. Oh, we don't need that. Just uncheck that and leave it. And that's pretty much the only thought I gave for about the next 6 years. So after about 2012, I started to realize that PowerShell wasn't going to go anywhere, and it was going to be required for me to learn a little bit more about it. So I did a quick search and landed on the Microsoft Virtual Academy course, the PowerShell 3 Jumpstart, and spent the next 2 days learning quite a lot about PowerShell from Jason Helmick and Jeffrey Snover, and quite enjoyed the course. And that led me to the Learn PowerShell 3 in a Month of Lunches book, and PowerShell 3 Jumpstart also led me to the Power Scripting podcast, which thankfully led me to the Mississippi PowerShell User Group, which is what brought me here. And along the way there, I decided it was time, it was nice being able to take all these courses, listen to the podcasts, read all the blog posts. I decided it was time to start giving back. So that led me on the path of semi-regular blogging and finally presenting to other IT folks, which is why I'm here today. Where you can find me and contact me, you can find me on Twitter at FuseLam, LinkedIn under David Lamb, and I have 2 blogs. The Frozen Geek is my primary technical blog, and David's 2 Cents is a little bit more of a personal blog, but it does contain some technical content. It's more of I keep my training log in there, and so that's got a lot of details of what I learned this week. And after about the first 5 or 6 weeks, I actually introduced a PowerShell commandlet of the week. So it's some basic technical content, but unfortunately neither of those have been updated recently, probably not since March. So the plan is once we get out of the summer here and into the fall, I'll start blogging again. Alrighty, on to the outline. Now this has changed slightly from what was tweeted out recently. It's more just for some fine-tuning. So we're going to cover managing DNS records, DNS zones, and DNS servers. And unfortunately, I took a look at it, and the timing just did not allow for full coverage of DNS Sec. So I've still included some DNS security in here, but the portion on DNS Sec was about 15 to 20 minutes to do it any kind of justice. So with regret, I won't be able to include that today. Alrighty, so moving onwards then. Managing DNS resource records. So first records are the A or Quad A records. These are your host records used for performing host names to IP address lookups. Your A records are for the familiar 32-bit IPv4 address, and the quad A records are your IPv6. Now, these are generally created automatically when a client registers with DNS, sometimes even with the assistance of the DHCP server, but they can also be created manually. Especially if you have an internet-facing DNS server, you may want to create these host records yourself. And certainly if you have older devices that also can't do dynamic updates. There are PTR records. Those are your pointer records. These are for doing lookups the opposite way around, for IP addresses to host names. These are also registered automatically when the A or quad A records get registered, but only if the reverse lookup zone exists. And the catch to that is the reverse lookup zones aren't created by default. So if you do need reverse lookup zones, you're going to have to create that manually before you get any PTR records. CNAME records, your canonical names, these are your aliases to host records. So, for example, say you have your finance department has a web application they go to that you keep on appfinance01. Well, all they have to do is go to bigmoney.contoso.com, but in the background you've got it going to a different name altogether, which is really handy if you have to migrate that service somewhere else in the future, because you can migrate that to webnode3-finance.contoso.com, and your finance department can still go to bigmoney.contoso.com and not worry about all the changes you made in the background. Mail exchange records, those are used to locate your mail gateway. So, for example, when an email is sent to your company, the sending mail server will query your company's DNS for that MX record in order to locate the IP address for your mail gateway so it knows where to send that mail to. The start of authority records indicates which DNS server is authoritative or responsible for that zone. And it's also used to determine how data is propagated to secondary servers. Now, the place where that differs slightly is in Active Directory integrated zones, where DNS has multi-master replication set up. So each DNS server that's hosted on a domain controller has its own start of authority records. You'll actually have multiple DNS servers that are authoritative for that zone. And name server records, those list the name servers for the zone, provide the host name for lookups. And finally, your SRV records, is your service locator records, are used to assist the clients in finding services on the network. Now, a very common example of that is for finding domain controllers for when the workstation first boots up. Now, one important thing to note, this record is not registered through the normal dynamic updates or through your register DNS client commandlet or an ipconfig register DNS. If you need to re-register your SRV record, either for an IP address change or the record goes missing or gets corrupt, what you actually need to do is restart the net logon service in order to re-register the SRV record for that server. And on that note, I'd like to thank Microsoft for giving us restartable Active Directory. That is definitely a time saver. All right, let's move on into our first demo. All right, so simply first one just for viewing all the records in the zone is just a get DNS server resource record, and you can optionally include the zone name for contoso.com in this case, and that gives you a full list of all the resource records in that zone. Now, one thing I do like about this view that PowerShell gives us is if we go over to, if we go over to our DNS manager into our forward lookup zones, you can see there's quite a number of folders Some of these go quite a few levels deep, and it takes a while to sometimes drill down and find what you're looking for. It's a lot easier, I find, to look for, if you're looking for records, to do a search through PowerShell. Now, you can also look specifically for, if you're looking for a resource record type, if you want to look for just host records, shorten the list down a bit there. Or say, for example, you want to look for the records, your host records, where your host name does not equal an @ symbol. Now, the @ symbol is just simply these records here where it says same as parent folder. So you can do a quick search for those, and that gives you a much shorter list. And you can also shorten it down by looking for records where the time to live is greater than or equal to 15 minutes in this case, and that gives us just our domain controllers. And you can also look up ones from other zones. For example, here we've got one on computer name DC3, zone name canada.contosa.com. Again, we're just going to look for resource records where the host name does not equal same as parent, and that gives you the resource there. How are we doing so far? Is everybody, am I going too fast? Any questions? Nope,
Yeah, I'm good.
All right, I was going to say I'll take the silence to say everything's, no news is good news. All righty. On to host records. Now, adding host records is fairly simple. You have to add DNS resource record A, and as you can imagine, there are a whole host of commandlets. Some have quad A, some have PTR, some have CNAME. There's a whole host of commandlets for specific record types. So in this case, we're going to create one called webapp25 in the zone contosa.com. Its IP address, easily done. And we're going to create one for our Red Deer printer. Again, same zone, get its IP address, done. And then we get an email back from corporate saying that, well, it's great you created that, but you used the wrong naming convention, and you created it in the wrong zone. So, not a big deal. It's easy enough to remove DNS resource records. Again, specify your zone name, your host name, and your resource record type. And you can put a -force if you want to force it to, if you're absolutely sure that's the right record. I prefer just to leave that off and let it pop up a quick confirmation, just so I've a little bit more secure there. And we'll create the new one with the CYQF, which is the airport code for Red Deer, and we're going to put this one in canada.contosa.com, where it was supposed to be in the first place. So that's that one. All right, let's move over to our PTR records. Again, as I said, add DNS Server Resource Record, and this one has the PTR, your IP address as the last octet of the IP address, the name for the printer, what zone it's going to be created in. You'll notice the reverse lookup zones are written backwards way around, so instead of being a 192.168.2, you write it backwards with a .in-addr.arpa. And we're going to create that one on DC3, which is our one for canada.contosa.com. And that pops up an error, which, as I mentioned earlier, the zone was not found on server DC3 because reverse lookup zones are not created by default. Not a big deal. We can just do an add DNS server primary zone, again to DC3, give it the network address range you need, and specify your replication scope. And in this case, and in most cases, I prefer to replicate that out to all domain controllers in the forest rather than just limiting it to the local domain. Let's put that in place. Let's make sure we've got our reverse lookup zone on DC3 by doing get DNS server zone. And there is our reverse lookup zone. So now we can go back and recreate our reverse lookup record. Taking a quick look there. Make sure I'm on the right line. There we go. And there's our record for our reverse lookup record for our printer. All right, CNAME records. Again, we're going to create one for the finance web app, which is going to point to the webapp25.contoso.com. It's just simply, again, just an add DNS server resource record CNAME in this case. So, easy to create that. And again, if you need to look up, just do a get DNS server resource record for your zone and the type of records you're looking for, and there's our record for that one. And finally, our SRV records. I said if you do a registered DNS client, that doesn't actually re-register your SRV records. What you need to do is do a quick little restart service-name, net logon. Give that a moment to restart. And it looks like we're back up and running. Just do a quick verification. And we're back up and running. And that's a far cry faster than having to reboot like we used to have to do in the past. All right, so is there any questions so far? Nope, everybody's all good. I will... If we're all good, then I will continue on to the next section. So managing DNS zones. So we'll quickly go through the zone types. There's our Active Directory integrated. Now these are replicated to all DNS servers running on domain controllers. Now that can be either limited in scope to just the domain controllers in the local domain or to the entire forest. But they can also be replicated to a custom-created Active Directory partition. And they can also be used with read-only domain controllers. But what that does then, it creates a read-only DNS server. So if there's any updates need to be made to the read-only DNS server, then those changes actually have to be forwarded onto a writable DNS server in order for the changes to be made. Primary zones. Now, in this case, we're referring specifically to the non-AD integrated primary zones. These ones are not hosted on domain controllers and are file-based versus being Active Directory integrated. Now, one drawback to this model is the transfers of zone data to the secondaries cannot occur if the primary zone is unavailable. But one advantage where these are well suited, though, is for internet-facing DNS, for your corporate internet resources, whether it be web servers, SharePoint portals, email, what have you. They're definitely better suited for that internet-facing versus your internal resources. And the secondary zones, these aren't hosted on a domain controller, and these ones absolutely have to be file-based. There's no option to make your secondary zones Active Directory integrated. But they can, however, be a secondary zone to an Active Directory integrated primary zone. Now, again, this is in a place where it's best used, or it's best used when there's infrequent updates. Again, such as your internet-facing DNS, where you're not going to be changing your IP addresses for your web servers and what have you. Your reverse lookup zones, now we covered those briefly in the previous demo. Those are for mapping your IP addresses back to the host names. Those can be configured as either an Active Directory integrated, a primary, secondary, or even a stub zone. None of those stub zones, those are actually used to point to the authoritative name server records for whatever the target zone is. And those, your stub zone contains, the only records it contains is a start of authority record, the name server records for that zone, and the host records for those name servers, which are actually commonly referred to as glue records.
Hey, David.
Yep, go ahead.
On stub zones, one thing I always get confused with is what's the difference in a stub zone and using conditional forwarding?
You beat me to the punch there. I was just going to get to that. Your conditional forwarders. they do basically the same job, but where a conditional forwarder is not quite as flexible is that you actually have to manually update the name server records for a conditional forwarder, whereas a stub zone, those, because you're pointing to the start of authority, if there's any changes to any of the name servers and they move to different IP addresses, those get dynamically updated. So that's one advantage of a stub zone over a conditional forwarder. And I think there's some discussion as to which one's better, and really I think it's personal preference. I prefer to use stub zones just because of that automatic update, but conditional forwarders are also do a very, very similar job. Does that clear things up a bit?
It does. Thank you.
All right. Okay, on to global name zones. Now, these are used for doing the single label name lookups. For anyone who's been around for a while is familiar with the good old Win server. So this is a more modern replacement for that particular service. Now, it doesn't replace it exactly, because unlike Win's, your global name zone has to be updated manually. Whereas Win's would just populate it with all the names dynamically. So usually what you want to use it for is for those last few remaining applications that require a single name label lookup. And so it's not going to be a huge zone of, you're not going to have a whole pile, you're going to have thousands of records. You're probably only going to have a few dozen records. But the entries in the global name zone, it's interesting to note, are actually just CNAME records that point to the existing host records for other zones. Now, replication to custom Active Directory partitions. Now, this allows you to specifically target which domain controllers will replicate this information. So, say, for example, you have a development environment at your corporate HQ, and you just want to be able to limit that to, a handful of domain controllers. And you don't want it replicated out over your entire corporate wide area network. So this is a good place to create a custom Active Directory partition, create your zone for your development environment, and then just replicate it out to those handful of domain controllers. And just kind of keeps your replication traffic under control. I'm not going to go into a whole lot more detail on those, as it's a bit more of an advanced topic, and on that note, of course, there's not going to be any demo for that either, but that's one of those things in the future I'd like to do a couple of posts on, just to kind of clear things up and how to make those, how to create them and make them useful. Zone aging and scavenging. Now, this reduces the chance of stale records lingering in the zone. So now these are records that are out of date or no longer relevant. Mobile devices tend to cause these issues more often, as you may have a mobile sales force that they're in and out of the office on a fairly irregular basis, so they don't always get the same IP address each time they connect. Now this can cause some performance issues with DNS in that it's trying to look up the stale record and can result in incorrect information being returned to the clients. By setting aging and scavenging on the zone to assist, you can actually remove these stale records, and depending on how aggressive you want to be on that, you can set that down to just a couple of days, or you can leave it at a couple of weeks, depending on what your needs are. And finally, DNS delegation. As I pointed out, this is zone delegation, not delegation of administration. This actually refers to pointing to child domain DNS servers. So, for example, I have a domain called contoso.com. When I created a child domain called canada.contoso.com, which is gives you a contiguous namespace, one of the options in there was to create the DNS delegation in the contoso.com zone. So what that did in that zone was created a pointer to canada.contoso.com from the parent domain. Now, the only entries that are in that delegated folder are the name server records for canada.contoso.com. But that's all that's required, is then your DNS server knows where to point to go for the next level of queries. And queries, as I said, queries for that zone are handed off to or delegated to that child domain's name servers. So that means you don't have to have your entire corporate DNS infrastructure in one single zone. You can actually break it up across multiple name servers in multiple domains. Alrighty, if there's no questions, I'm going to proceed onto our demo for DNS zones. First one, very simple here. Clear this out. Just a get DNS server zone. And that just gets all the zones on the current server that you're on. So in this case, you can see we just look at our reverse lookup zones and our contoso.com zone. But we can also look up on specific DNS servers. So in this case, we're going to look up on DNS4. And that gives us, in addition to our reverse lookup zone, which has been replicated out to the entire forest, we now have our wingtiptoys.com zone, which we will come back to in a little bit. Also, get DNS server where reverse lookup zone is equal to false. So what this is going to do is this just gives us our forward lookup zones. So that shortens the list down quite considerably. Something else you can always do, you can always check to see which of my zones are Active Directory integrated. So we'll run that. That shows you these are just the ones that are Active Directory integrated. But if I want to go further than that and say, where are these forest or domain replicated? It's easy enough to do. Just say similar query with select zone name and replication scope. Oh, and there we go. And that shows you I've got 3 that are forest replicated zones and 1 that's our domain replicated zone. All right, moving on to creating an Active Directory integrated zone. Fairly straightforward. Add DNS server primary zone. Give it a name, in this case frozennorth.ca. And what your replication scope is. So very similar to creating the reverse lookup zone. Now, one thing that's somewhat useful if you suspect you've got a zone on a server that's not being updated properly, what you can do is run the start DNS server zone transfer, specify which zone you're looking to update and the server that you're looking to update it on. And then if you specify full transfer, that takes all of the records that are currently in the zone and transfers them versus doing a incremental transfer. Now, unfortunately, if you run this right away, you get an error, mostly because of the reason that frozennorth.ca hasn't replicated over to that domain controller yet. So you have to be a little bit patient before you can start pushing out updates to your zones. Reverse lookup zones we've done previously. So just quickly create another one on DC1. There's our 172.26/16 network ID, and again, replication scope is forest. Easily done. We can look that one up if we look here. And there's our new zone, and in addition, our frozennorth.ca zone. All right, down to stub zones. Now, in this case, what we're going to do is we're going to create a stub zone to point to one of our corporate partners' DNS servers so that we have access to his name resolution so that we can establish an Active Directory trust relationship with them. Now, it's important to note that if you are going to create an Active Directory trust, you need name resolution first. So in this case, we're going to go add DNS server stub zone, name Northwind Traders, master servers, load existing records, and replication scope again. We're going to replicate out to forest. Now if we go back and do a quick lookup, now you see we've got our one listed as a stub zone. All right, on to global name zones. Now this is just, again, an add DNS server. It's just a primary zone. The catch is that you have to name it global names, exactly as it's written here. Okay, we're going to replicate this out to the forest. And once you've got that created, the one thing you do have to do before it becomes active is you have to run the set DNS server global name zone commandlet on each domain server, or each domain name server that's going to be on a domain controller throughout the entire forest. So in this case, we created a quick for each to walk through the whole list, and they're now all enabled. So if we do a quick add DNS server resource CNAME record, zone name, global names. And what we're going to do here is we're going to create a single label lookup for an old application the finance users are using. And it's looking for the single label finance apps. So we'll create that, point that to the web app 25 again. And done. We'll check that. And that shows us our CNAME record has been created. And we'll do a quick check and make sure our global name zone is in there. And there's our global name zone. Again, it's just as a primary zone. All right. Zone aging and scavenging. Now what we're going to do is we're going to take a quick look at the using the get DNS server zone aging for the frozennorth.ca domain. Now this is going to be our domain for our mobile Salesforce users for all their mobile devices. So what we want to do, if you notice here, we've got aging enabled, that's turned off at the moment, and our refresh interval and no refresh intervals, which affect the time frame that those records are removed and cleaned up. Those are set to 7 days each. So if we do a quick set DNS server zone aging for frozennorth.ca, turn aging on with true, and we'll shorten down our refresh and our no refresh intervals down to 3 days instead of 7. So we take a look at that. And that shortens that down. Now I do have, if anyone's interested after, just let me know, I do have an article I posted about a year and a half ago that goes into a lot more detail explaining how the refresh interval and no refresh interval affect the aging and scavenging. It took a bit of figuring out, and it's not always inherently clear. So if you're interested in picking up that article, let me know afterwards and I'll point you in the right direction. Now, as for setting up DNS delegation, now for our canada.contosa.com zone, I set that up automatically when I first created the zone. But it's just an add DNS server zone delegation. Set up the name of your parent zone. The child zone name, in this case, was Canada. Name server on DC3, which is Canada's domain controller, and the IP address. And that would have that set up for you. So if you were setting up a DNS server in an internet-facing DNS server, or you simply had a zone that you were using for a development environment and you didn't want it was not integrated into your Active Directory, you could set up that zone delegation just to offload some of the name resolution to that DNS server specifically. But what we are going to do here, however, for tree domains, now those are domains in your Active Directory that don't have a contiguous namespace. So in this case, Wingtip Toys is one of our Active Directory domains, but it's not in the same contosa.com namespace. So what we need to do here is add a DNS server stub zone for wingtiptoys.com. Master servers listed, load the existing records, and master or replication scope to forest. And that does that quickly enough. And we'll do a quick check our zones here. And those ones again get listed. Let's see, Wingtip Toys and Northwind Traders are both listed as stub zones. And that, if we do a quick DNS server resource record, zone name Wingtip Toys, that gives us, again, our start of authority, our name server, and our glue record. And that brings us to the end of managing DNS zones. So, any questions so far? Are we all good? Am I going too fast? Do slow me down if I'm going too quickly.
The speed's good for me.
Alrighty. Good to know. I did a quick run through yesterday and recorded it and played it back for myself, and I thought, I'm talking kind of fast here. But there is a lot of material to cover, so I'm going to keep pressing ahead here. Managing DNS servers, DNS logging. Now, this is for capturing events related to the DNS server, whether it be just service starts and stops, zone loading and signing, modifications to the DNS service configuration, and then just other general DNS warnings and errors. And there is some DNS debug logging that can be turned on, but realistically, that is a session all on its own. As far as the event logs go, these can be found in the Windows event logs under the Application and Services /DNS Server. And by default, all events are captured in the event log unless you turn down that level to just errors and warnings or just errors. But generally speaking, unless something has gone horribly, horribly sideways, you're not going to see a lot of DNS events. Forwarders, now those are used when you want to specify a DNS server to handle DNS queries that your local DNS server is not authoritative for. Now usually it's configured to be your ISP's DNS server, but not in every case. It saves your DNS server from having to perform those iterative queries all the way up to the root DNS servers on the internet. So it can just take the query, pass it up to its forwarder, and get the answer back and have the forwarder do that query for you. Now this unfortunately has to be configured on a per DNS server basis. It's not one of those things you can integrate into Active Directory and have it replicate around. But then again, using PowerShell, it's not a big deal to configure all your DNS server forwarders all in one quick swoop. Conditional forwarders. Now these are designed to forward queries for domains that you specify versus just any domain. So usually for domains that you already know the IP address of the name server for. For example, if you have a large multinational corporation, you have many, many different divisions. Well, they may all choose to share their name servers with each other so that everybody can set up a list of conditional forwarders so you can get to all the internal resources for all the different domains and divisions. Now, conditional forwarders when doing queries actually takes precedence over general forwarders. So the first thing your DNS server will check if it's not authoritative for the zone is it will check its conditional forwarders first to see if it has a matching domain that it can forward the query onto. And if not, then it sends it on to the forwarders. Net mask ordering. If you have multiple records exist for a particular query, this one allows the DNS server to return an address that's on the client's own subnet if there's a record that exists. And by default, this is enabled on Windows Server. Round robin really is a poor man's load balancer. You have multiple hosts can be configured with the same host name, so that when a client request comes in, it gets given the entry that's at the top of the list. So, for example, if you have 4 or 5 servers, all with different IP addresses, but they're all labeled www. What it'll do is it'll hand that first entry back to the client, and then take that entry and put it at the bottom of the list. And then the next client request that comes in gets the next one along the list, and so on and so forth. Now, the problem with that is that DNS round robin doesn't do any service verification. It doesn't check to make sure the service is actually available on that server. So it can actually hand out an IP address to your client, and that particular IP address that server is offline temporarily. So not a great idea. For something like that, you want to look at using network load balancers more than relying on round robin. But that is there, and that also is enabled by default. And last in this list is the caching-only DNS server. Now, these DNS servers are not authoritative for any zones. They simply receive requests, perform the query, cache the results, and pass the answer back to the client. And the longer they stay running, the larger that cache gets. All right. We'll head back over to our demo for DNS servers. Now, if we take a look here at this first one, this is your Get DNS Server Diagnostics. Gives you a whole list of various diagnostics that could be turned on and turned off. What these are, if we look at our DNS console again, go to our server properties, that is actually this debug logging tab. This is the same list of options that are listed on the side, but you can actually set them with the Set DNS Server Diagnostics. But like I said, we're not going to cover that in any great detail today because it's can be quite a lengthy topic on its own. But if we do check the event log for use our get event log name DNS server, that gives us a list of our events. Like I said, not a lot of events in the event log. Because unless it's gone, like I said, unless it's gone horribly sideways, you're not going to see a lot of events in there. But if you want to do a check across all your DNS servers for warnings and errors, and then put it in a table with your machine name, event time, whether it's a warning or an error, and the instance ID. That gives you a nice little table. It gives you a quick look at what events may or may not need looking at. Now, these 4013 and 4015 errors tend to be, these are related to the Active Directory integrated zones, usually when it cannot contact the zone initially. So that's why you don't see a whole lot of them for today, is because everything was up and running. So there's not going to be a lot of those in there. Okay, on to forwarders. Oops, wrong window there. Let's try that again. There we go. Forwarders. If you do a quick get DNS server forwarders, this shows you which ones are configured. Now, in this case, I'm using Google's DNS servers for forwarders for this DNS server. But if we wanted to add one, and do a set DNS server forwarder, give it the IP address we want, and add that in, and go back and take a look and verify, and then we find one of those gotchas for this particular commandlet. It overwrites your entire list. So if you're going to want to add a forwarder to your list of forwarders, make sure you add all the forwarders you want and put them in the order that you want them searched in. So we'll run those, and now we have all three forwarders in there. And you also notice it's set to use root hints. Now what that means is that this timeout value is set to 3 seconds. So if it checks the first one, doesn't get a response, checks the second forwarder, doesn't get a response after 3 seconds, and the same with the third one. If it gets all the way to the end of those three and still doesn't get a response, it will actually resort to using the root hints and perform an iterative query all the way up to the root hint servers and work its way back down. Now, conditional forwarders. If you take a quick look here, you see we don't actually have any conditional forwarder zones set up. So what we're going to do is do an add DNS server conditional forwarder zone for the name tailspintoys.com. Set up the master servers for that, and set our replication scope again out to forest, which is one of the nice things about the conditional forwarders is you can actually have it replicated through your entire Active Directory environment. So put that in place, do another quick search, and there's our forwarder for Tailspin Toys. Let's see. Now, NetMask ordering and round robin. I'm not going to do a demo on those. I haven't found an easy way to configure them short of using PowerShell to edit the registry, which can be fraught with peril if it's not done quite right. So I'm going to skip over those for this session. We're going to move on just to caching only DNS servers. Now, in this case, all you have to do if you need to set up a caching only DNS server is simply install the DNS server role to a Windows server, ensure the root hints are configured correctly, and don't set up any zones on the server. Now, if you want to see a list of the root hints, you can simply do a get DNS server, computer name DC01, and dot root server root hint, and that gives you a list of the root hint servers. And you can check those on any and all of your. Now, for some reason, these ones are only showing the IPv6 addresses, and I haven't quite figured out why, because sometimes I'll do this and it'll show up IPv4 and IPv6, but in this case, we're only getting IPv6 addresses. All right, that brings us to the end of our DNS servers demo. Any questions, comments, concerns?
I would say that that list of root hint servers just depends on which interface you're connecting to on that box. So you're probably talking through the IPv6 since it's local, so that's what it's returning to you, versus if you forced a connection on a different interface, then you would get the appropriate hints for that one.
Yeah, that actually makes sense. Yeah, that's very likely what's happening there, yeah. Thank you for that. That clears that up for me a bit. Sometimes I overlook those simple things. It's like, oh yeah, we got multiple interfaces. I forgot about that. All right. Well, if there's nothing else, then we'll move on to a quick review of DNS security. Some of the settings you want to configure. Cache locking. Now, that enables control over when information in the DNS server's cache can be overwritten. Now, cache locking provides greater security against cache poisoning attacks, where an attacker may try to inject false records into the cache. And it does that by preventing the DNS server's cache from being overwritten until the configured percentage of the time to live value has expired. So, by default in Windows Server DNS, it's actually set to 100%, and it's been that way since Server 2008 R2. And whilst yes, you can lower that percentage value, I don't see any advantage to it. But there may be some edge cases where you need to shorten that cache locking percentage. Next one down is our socket pool size. Now this makes cache tampering and spoofing attacks more difficult by randomizing the source port where the DNS servers issues its DNS or issues recursive queries to other DNS servers. So now, in order for an attacker to spoof the DNS server with the incorrect record, the attacker now has to guess not only the randomized transaction ID, but also has to guess the randomized port that's used. Now, DNS servers running on Server 2012 and 2012 R2 use a socket pool size of 2,500 by default. But those can actually be configured anywhere from 0 to 10,000. Although I would caution against using a socket size of 0 or socket pool size of 0 because that limits your DNS server to a single socket, which is going to be considerably easier to guess. And finally, recursion. Now, if the DNS server can't get an answer to or cannot answer a DNS query from a client, it performs a recursive query on behalf of that client and returns the results. Now, this works out well for internal servers, but for an internet-facing server, that opens up that server to an attack where an attacker can flood that DNS server with requests for queries that it's not authoritative for, so it has to perform all those recursive queries and can actually just bring that DNS server right down to its knees. So in order for to prevent that, recursion should be disabled on internet-facing DNS servers, and that will greatly reduce the chances that somebody's going to be able to perform a denial of service attack on, certainly by performing bogus recursive queries against your DNS server. All right, let's move back over to our final demo for DNS Security. Now, if we take a look here, we can do a get DNS Server Cache, and that shows us our cache enabled pollution protection is enabled, and our locking percent is set to 100%. But it's easy enough to change that with a set DNS server cache, locking percent, and set that down to 80%. Easily done. Like I said, not sure why you might want to do that, but like I said, there's probably some edge cases out there that I'm not aware of. As far as socket pools go, I haven't found a PowerShell commandlet, but you can use the DNS command /info/socket pool size to view your socket pool. And again, same config /socket pool size. We set that to 8,000 to increase our socket pool size. Oh, hang on. Try that again. There we go. And that sets that to 8,000 now. And you can actually check the path in the registry where that's set down in system current control set services DNS parameters. And that also gives you a look at where your forwarders are configured, your forwarding timeout, shows you your cache locking percent. A lot of things in there for to have a look at, but not somewhere where I think you'd do a lot of changes. You can also look up your socket pool size just by doing get DNS server settings socket pool size. That just simply returns your value of 8,000. And finally, on to recursion. You can check your recursion settings. So in this case, we're going to check our recursion settings for the canada.contosa.com DNS server, and we find out that recursion is enabled. Simple enough to turn off. You just set DNS server recursion, computer name DC3, enabled, false. And that turns off recursion. Now, obviously, you might not turn it off on an internal DNS server, but certainly an internet-facing one, you might want to consider that. And there we go. You see enabled, false for recursion. And that wraps up that particular demo and our presentation for tonight. So any other questions, comments?
I do have one question that's actually been bugging me. I wonder if you know the answer. When you go back to creating your DNS zones, I've used the create zone commandlet before, but it creates them all at the root. So, for example, if you are trying to replicate an Active Directory infrastructure DNS on say a primary zone server, if you do the create zone and you create the _TCP, etc., all that kind of stuff, it in my experience, it creates everything at the root, so it works. I mean, it does get the appropriate resolve to come back. But how do you create do you know how to create the sub-level domains, like nested foldering inside the DNS?
Not off the top of my head, because you see, if we look at the ones that were created here, like Frozen North, that just has the initial records set up in it. Usually, you're talking about all the folders that you see in the like all your _TCP folders and all that.
And you can say, create me a new primary zone, contoso.com _TCP, etc., and it puts them at the root, and obviously the path is there, so the lookup succeeds and is correct.
Mm-hmm.
It's just ugly, very ugly.
Yeah, not set up quite the way you might think makes a lot of sense. Yeah. No, I haven't had any experience with that specifically. Usually, most of the zones I've been creating have been either automatically created by, when you do a domain controller promotion or setting up a new domain. But no, I haven't had any experience with that.
All right. Well, thanks.
As I mentioned sometimes to some of our clients, thank you for contacting the no help whatsoever desk.
It's been very helpful. I've enjoyed the presentation. I've picked up a good number of things. Thank you very much.
No problem. I'm glad you were able to get something out of that.
I agree. It was a very, very good presentation.
Oh, well, thank you very much.
Thanks, David.
Yeah, I picked up a number of tips as well. I've used the DNS commandlets, but not just very basic stuff.
Yeah, it was, even when I was putting it together, it was kind of surprising. I thought I had a fairly good grip on DNS server commandlets, and as I started going through it, I was like, oh, that's kind of cool. I didn't know you could do that. And yeah, even myself, I've learned quite a bit just putting this presentation together. Oh, yeah, Greg, yeah, you were talking about the article for the aging and scavenging. Is that correct? All right, just give me about 1 minute here. Actually, I'm just going to, if you're all right there, Mike, I'm just going to stop presenting.
Sure, that'd be fine.
There we go.
All right, so I guess he's going to get that blog post for Greg. So what everybody think?
I enjoyed that. I was a little bit late. Finally made one of these meetings again, and it's always very educational. I enjoy it. It's good to hear from Mike and Ron, y'all two again.
Yeah, good to hear from you too, Alan. David, thank you again for seriously, that was a very, very, very good DNS presentation.
Oh, well, thank you for having me. It was a lot of fun.
You guys have a good night.
You too.
Thank you.
I'm heading out. It's way past my bedtime. All right, talk to y'all later.
Thanks, guys.